What it is, people literally just got up like 15 minutes ago and now I'm recording a tutorial. What about that? Smash a like! Anyways, back at again with another, and this one is a 3D infinite runner game. Yes, I call it the way of the ninja. We have a ninja and all the cool stuff. So let's get into it and first see what is the game that you're gonna create. So when I hit the play button, magically the level is going to appear in front of me. Let me just lower the volume. And now we need to avoid all of these obstacles, of course, if we want to win the game. And I am the ninja like no other, as you can see. And we can see the exit over there. Look at the white thing, but now I don't think... and I died. Yeah. So let's try it again. So let's go here and run and so on and so forth. I need to do it actually here so that these spikes don't kill me. And move away. And I'm pretty good at this game, man. But as soon as we are near the exit and we don't see it anymore, because we are creating our levels procedurally, which is really cool. But hey, this is your game. I'm gonna die now. And yeah, I died. So yeah, this is our game that we are going to create. And spoiler alert, there is no ninja. If I go here, just the first person controller, as you can see. Tricked you there, buddy. Anyways, but no, seriously, it's a really cool game. We'll see how we can create all of these cool effects, how can we make the ninja run, and so on and so forth. You saw the game, I mean, smash a like and subscribe, man. Again, as always, you can download the assets and the complete project. Link will be in the description below. And I'm left without any clever words to say, so I guess let's get into the video. Alrighty then, we are in a new project. It is a 3D project, so the first thing that I'm gonna do is I'm going to select all of these models, prefabs and blah blah blah, and I'm going to drag and drop them right here inside of my project. Of course, we will need to wait for Unity to import because we have some 3D models, and that is how it goes. That's life. You need to wait for everything that is good. Okay, so if you have anything here, just ignore it. So because you guys start to panic a lot when you see something here in the console. Oh, I see something. Just ignore it. Clear the console. You can run the game, no problem. So, what is the first thing that we need to do? First of all, we're gonna create our imaginary ninja. So I'm gonna right click here in the hierarchy and create an empty game object. And this game object, I'm going to call it FPS controller or ninja controller, however you want to call it. I'm also going to set here Y position at 2 and the Y rotation at 90. So it's 90. And basically that is that for our ninja. I'm also going to attach a box collider and a rigid body. So rigid body like this. So for the rigid body, I'm going to set its mass at 50. For the constraints, I'm going to freeze all rotations. So X, Y, and Z. What if I tell you that I have more tutorials with better explanations and a more comprehensive guide than this one that you're following? Sounds interesting? Well, that's my Game Development Academy, and inside you have more than 80 courses, more than 500 hours of content for you to learn game development with Unity, Unreal Engine, and everything in between. So, click the link down below and check it out. And for our box collider, the size X is going to be 0.17, size Y 1.63, and size Z is going to be 0.28. Because I want it simply like this. I don't want it to be any large because we have spikes, we have all those enemies or those obstacles that are going to kill us, and yada yada yada. I'm also going to go here and attach an audio source component on it. I am going to uncheck play on awake, and here for the clip, I'm going to filter this death, okay? Because, well, then we die. Okay. So, what is the next thing to do? The next thing to do is program our player controller. So I'm going to right click here in the assets and create a new folder. This is going to be my scripts folder. Inside of this one, I'm going to right click and create a C# script, and I'm going to call this one player controller. And by the way, I did forget to do that. So we do need to attach the main camera as a child of the FPS controller. So the main camera is a child of the FPS controller. The X position of the camera will be 0, the Y position will be 0.8, and the rotation Y will be 0. So yeah, because we are going to control the camera like this, you see? we're going to control the camera with the FPS controller. So make sure that you attach the FPS controller or camera as a child of the FPS controller. And the position Y will be 0.8, 0 for X and Z. Scale or rotation will be 0 for all three axes. And the scale, we're not even going to touch it. So now we can go back, and did I attach the FPS controller on the player? No, I did not. So I'm gonna drag and drop it, attach it on the player controller or FPS controller. I'm gonna go here and voila, open this in Visual Studio. Let me just tag the class, give a little bit of space because we are going to put some really cool code here. What do we need for our player controller? First of all, we need a rigid body. So private rigid body, my body. We also need a public, so public float, and this one is going to be forward underscore speed. By default, it's equal to 8. We're also going to have the move speed, which is by default 8, and we're going to have the jump force underscore force, come on man, which is going to be equal to by default 300. Next, we have our private vector 3, which is going to be move direction. So move direction, this is going to determine where we are going to go. So move direction by default, vector 3 is equal to 0, like this. We are also going to have a private float movement underscore Z, a private bool that I'm going to call can move, and a private audio source like this that I'm going to call audio FX. Voila, simple, very, very simple, not that much. We already know what all of these are. I mean, we know what is an audio source, we know what is a rigid body, there is no need to explain all of that. In the awake function, we're going to get a reference, so my body is equal to get component, rigid body component. We're also going to get the audio source, so audio FX is going to be equal to, again, get component, but this time audio source component. And we are good to go. So now we need to, let me come on, go back here. So right here below the update, I'm going to create two functions. First one is going to be void character move, like this. Below, I'm going to create void. This one's going to be player or character jump. So character jump. And both of these, we're going to call them in the fixed update. So let me just copy this, and this one's going to be fixed update instead of the update because we're going to use physics to move our character and character jump. So both of them are there. Now in our character move, the first thing that we're going to do is we're going to test if we cannot move, we're going to return, because when we die, we're not going to allow the movement. And notice the exclamation mark. I did this a numerous of times. The exclamation mark will make what's after the opposite. I'm explaining this for the newbies who are here. So the exclamation mark will make what's after the opposite. If can move is true, this will make it the opposite, which is false. If can move is false, this will make it the opposite, which is true. So essentially here in this line of code, we're asking if we cannot move, then return. Return will simply exit out of this function. When we hit the return in a void function, it will exit outside of the function. It will not execute any code that's below it. That is why we use return. Voila! So now, if our input dot get axis raw, and I'm going to get the horizontal axis, if that value is greater than 0, we are going to move to the right side. Else if input get axis raw horizontal is less than 0, and here else if we are not touching. So if we are touching, if horizontal is greater than 0, what we are going to do? We are going to say our movement, so movement z, is equal to the negative of the speed. So why the negative of the speed? Well, because we are going to move our character on the x-axis. That's how we rotate it. And if you're wondering why did we rotate, well, because if I go here in my prefabs, I have corridor 1 as the first level. If I put it here, that's how the levels are arranged. That's how the levels are arranged. So voila. And the front, and let me just go here in lighting, auto generate, turn that off because we are going to have problems. So let's go here in the scene, and if you pay attention here, the FPS controller, if I take him and I move him like this, his x-axis is moving forward. Pay attention to the x-axis value. Currently it's 0. If I move him forward, And you can see that I'm moving him forward like this, you see, forward, but I'm moving it on the x-axis. That's how we rotated him. So we're not gonna move him on the z, but even though I said it z here because we're moving forward, that's the point. So here we're going to say negative of the move speed. This is for the, oh, actually, excuse me, this one is for the z, actually. What am I saying, man? I just woke up, man, sorry. So this one is really for the z because on the z-axis, we're gonna move him left and right, you see? On the z-axis, we're going to move him left and right, you see? So yeah, sorry for that one, sorry. Don't butcher me, don't be like, oh, I need to kill him. So, no. Anyways, on the z, we're going to move him left and right. But yeah, explaining why we're using z to move him left and right is because on the x, we're moving him forward. Okay. So here below, it's going to be the opposite. So here I'm going to say it's positive move speed when the horizontal get axis or horizontal is less than, or actually here it's less than 0. So yeah, and here we're going to say move speed is equal to 0 because we are not moving. And now simply in our move direction, we're going to say move direction is going to be equal to new vector 3. For the x, we're going to say forward speed. For the y, we're going to say my body velocity y. And for the z, we're going to say movement z. And then simply, we're going to say my body velocity is going to be equal to move direction. And we can test this out right away. I can go back here in Unity and I can hit the play button and we will start moving, or actually we will not start moving. And the reason for that is, and we will come to the animations of these obstacles, don't worry about that, I will talk about that as well. But the reason why we are not moving is because here we have the can move is set to false. So can move is set to false. What we actually need to do is here below, I'm going to say void activate movement. And here I'm going to say can move is equal to not ture, but true. And what I'm going to do in the start function here is I'm going to say instantiate, or actually, excuse me, it's invoke. And I'm going to say invoke activate movement in 2 seconds. So 2 seconds after we start our game, I'm going to activate the movement and I can go and now test it out. So if I hit the play button, now we will see that after 2 seconds we will start running. So now you will see, bam, we started to run, as you can see, and now I'm running and voila, you see, I can move left and right, and yeah, but basically I cannot go further or I fell down. So we need to fix that. But before we can fix that, let's go and create our player's jump. So I'm going to go back here in Visual Studio and in the character jump, so here I'm going to test if the input dot get button down, and for the button down I'm going to say jump, and this is depending on the platform you are on consoles or actually on PC, this is the space button. On consoles, I believe this is the X button, the default button you use to jump. So yeah, on PC it's the space button. So here what I'm gonna do is I'm going to test if my body.velocity.y is equal to 0. That is when we will be able to jump. Otherwise, no. Otherwise, it's a big no-no. So in order to jump, I'm going to say my body, add the force, and I'm going to add the force upwards, so vector 3 up on the y-axis. I'm going to multiply that with the jump force, and I'm going to say here force mode dot impulse. So force mode impulse is add an instant force impulse to the rigid body using its mass. So it's simply going to move instantly our game object upwards. And let me just show you that. So if I go back here, hit the play button. So pay attention now. When we start moving, bam, 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 you see, it's a really, really cool and nice jump. So really, really cool and nice jump. And I jumped all or outside of our, I jumped outside of the level, which is really cool. So yeah, anyways, the next thing that we need to do is start spawning our levels. So for that, I'm going to right click here and create an empty game object. And this is going to be our level spawner. Now I'm going to position him at the 0, 0, 0 for all axes. Before I create the script, we do need to attach a box collider on him, and we do need to resize him. But before we resize him, let's go here in the scripts, and I'm gonna right click here, and I'm going to create a C# script, and this one is going to be called level spawner. Now, before I resize him, I'm going to explain why am I going to resize him. So here I'm gonna go attach the script, double click it, and open it in Visual Studio. So what do we need here? Okay, let me just, do my regular crazy things that I do. Don't mind me, and everything is regular. If you are a regular on this channel, you know what I'm talking about. So what do we need here? It's a public game object array, and this one's going to be our levels. We also need a private float. This one is going to be level underscore distance, and that is going to be equal to 50. And here I'm going to say F. Below I'm going to say private float current level underscore X. That is going to be equal to 0. You're also going to have a private float increment spawner underscore X. That is going to be equal to 125. And private int spawn underscore count, that is going to be equal to 5, or actually this is an int, so we need to say 5. So before we proceed to create everything here, what I'm going to do is go back here in Unity and select our level spawner. So we need to attach these levels. So here we have levels. We are going to have 5 of them, and they are here in the prefabs. So go in the prefabs and drag from corridor 1 up to corridor 5. Very simple. Click on them, drag and drop them in the slots right here. So from 1 up to 5, 1, 2, 3, 4, and 5. We are done. What is the next thing to do? Well, the next thing to do here, we don't need the update. We do need void spawn levels like this. And in our, what am I doing? In our spawn levels, we are going to first create int random, which is going to be equal to 0 right here, just so that we can declare it. Then we're going to go here and say for int I, which is equal to 0. As long as I is less than the levels dot length, we are going to say I++, and excuse me for this one, it's not levels dot length, it's the spawn count. So it's the spawn count, or how many levels we are going to spawn. Here I'm going to say random is going to be equal to random range between 0 and levels dot length. And here I'm going to say GameObject.go is going to be equal to instantiate, and I'm going to instantiate levels and the index that's at the random, which is the one that we have just generated, this one right here. I've probably used random range 3 million times in my tutorial, so you should know what it's doing. So it's going to give us a random value between this and this number. And the length of the levels is actually how many elements we have in the array, which is number 5. So now we have our game object. Next, I'm going to say vector3 level temp. That is going to be equal to instantiate. And here I'm going to, or actually, excuse me, that is going to be vector3 0. So vector3 0. Next, I'm going to say level temp. So level temp dot x is going to be equal to current level x. And then simply go dot transform dot position is equal to level temp. Simple as that. And below here, we need to say current level x plus equals the level distance. Now, let me go here in the start and call this function so that we can see what is going on, so that I can explain more things, because we do need to do one more thing. And what is this right here? So if I go here and if I hit the play button, we will see that the levels are automatically spawned. You see, what is this right here? So how did I spawn so many levels? I spawned 5 levels, and I know that the distance between every level is 50. Because if I put them here, let's say this one, and then this one, corridor 1 on the X is at 0. Corridor 2, if I set it on 50, you see automatically it's gonna fit perfectly here at this spot. So I know that the distance between them is equal to 50. That's why I set that to be equal to 50 right here. Now, what is the current level X? Well, current level X, as you can see here, I'm positioning them. So current level X by default is equal to 0. So the first one will be positioned at 0, then the next one will be positioned, you see, plus equals levels distance. So next we are incrementing by 50, so that every next level will be positioned 50 units away from the previous one. That's why we have that. Now we do need to do one more thing, but I'm going to show you why. So I'm going to go here and hit the play button, and notice now when we start running and we go and we pass all of these obstacles, we will get to the point where we will not have any obstacles anymore. And you see, I don't have anything to detect collisions, so don't worry, we will not die. I should have died here, if that, and here, and probably here. So you see, we now see the exit, it's there. You see the white at the end of the tunnel. So when we reach to it, that is basically the end. And we're going to fall off and voila. So what we need to do with this, that's why I said I need to resize the level spawner. So what I need to do is the following. So the X size of our scale of our actually box collider is gonna be, so here it's gonna be 1, but here size X is gonna be 0.1, and for the Y it's gonna be 10, and for the Z it's going to be 10, you see? And what I'm gonna do here inside, and also don't make sure that you set it to be a trigger, and for the FPS controller, make sure that you set the player tag. So player tag for the FPS controller, and the level spawner is going to be a trigger. So what we need to do with our level spawner, if I go here in Unity and I click now here to spawn all these levels, and go here, you see this is where our level spawner is. You see this is where the level spawner is, right here. We don't want him to be right here, but what we want to do is outside of this if-else statement, I'm going to say vector3 temporary position is equal to transform that position. I'm going to say temp.x plus equals, so plus equals increment spawner x, and then I'm going to say transform that position is going to be equal to temp. Simple as that. This is going to take the current position of the spawner, add to it the spawner increment x, which is 125. It is going to position him at the position 125 for the x. And I can show you that if I go here, notice where our spawner is. It's right over there. You see him? He is right over there. So when we reach him, so let me go here and try to reach him. So now when we reach him, pay attention here to the, look at here. You see the white thing at the end of the level? So pay attention now how that white thing is going to go away when we reach the spawner. You will see in a moment or two, this right here, the white thing is gonna go away. Come on. Oh, actually no. How stupid am I? It's not gonna go away. We need to go here and we need to say void on trigger enter. And here I'm going to say target. And now here if our target.tag is equal to player, and now it is going to go away. So if we collide with the player, if the level spawner has collided with the player, now we're going to call spawn levels again, and now we are going to see that. And because we are still in the game, this current level X position has the current value with the plus equals levels distance. We will just continue to spawn new levels from the last X position of the last level. So it will just continue to go from there. And also here for our temp position of the level spawner, we're going to increment it again by 125, which means again we're going to position it 125 units away from the player. So now pay attention to that circle, or actually to that light at the end of the tunnel. So now notice now when we start going, look at the level over there. So when we reach when we touch the level spawner, we are going to spawn more levels. So come on. Can I get to see that? Probably not because of this fire and all of these things. Anyways, we don't see it anymore. You see, we don't see it anymore. We spawned more levels. You see, we spawned more levels, and our level spawner is way over here now. You see, it's at position 100 or 250. That's why I needed to resize the box collider. That's why I needed to reposition him. And yeah, basically that is that. So to wrap up our game, we need to go back here in our Unity script for the player controller. And here we're going to have void on collision enter. And here I'm going to say target. So if we collide with any of the deadly spikes, so we're going to say if target.gameObject.tag is equal to kill zone. And I already created this tag. It's in the game. Don't worry about that. So here, if we cannot move, I'm also going to say return, because I don't want to detect collision if we cannot move. Basically, this if can move, you can count it as player dead. So if we cannot move, we're going to say return. But if we can move, we are going to say my body velocity is equal to vector3 0. And below I'm going to say can move is equal to false. And below I'm going to say audio fx.play, so that we play the dead sound. And I'm going to simply go here and say invoke restart game like this, and I'm going to invoke that in 2 seconds after we die. But I don't have this function, and in order to have it, simply go here and create it void restart game. And here I'm simply going to call Unity engine.scene management, scene manager. So scene manager, come on, man. Dot load the scene, and here I'm simply going to say get active scene dot name. Voila, simple as that. So now when we touch one of these game objects, we are going to die, and you're also going to hear the sound when we die. So let's go back here. Let's try it out. Listen, you see, I'm dead, and now I'm gonna restart the game. So we see that that is working. The last thing that is left here is to go and create an empty game object. This is going to be our BG music, if you want to add that. So here for the transform reset, audio source. Here I'm going to say loop and play on awake, and I'm going to say ninja way, this is the track. I'm going to set the volume at 0.1. I think it's 0.1, so let me just see it over here. Yeah, it's 0.1. So this is our game, you see? And before we part our ways, let me just go here for the corridor and all of these cool things here. So if I go here for this corridor, and if I take one of these obstacles, so let's say for example, I don't know, great axe trap. So you see here, basically we have an animation attached to it. So I did not want to go into that. We did animations numerous of times. I covered that in depth in my courses. In a lot of my courses, I have a dedicated section only to animations. And again, we covered that here. But basically this is just positioning or moving the position, you see? This is the animation, and we have here the great axe. What we're simply doing is moving the position, you see? We're moving it from -60, then here to 60, then here to -60 again. So we're simply moving that position. Nothing special, nothing complicated that you cannot create on your own. And what we also have here is that we have a mesh collider. You see, a mesh collider is similar to a polygon collider in a 2D game. What is a mesh collider? Well, as you can see here, this game object has this shape like this. The mesh collider will make it collidable on all of its body. But what is the difference? Well, if I go here and attach a box collider, you see how that would look like. You see, the box collider will circle the whole game object, which means if I take my highlight tool, which means that this right here is also collidable. You see, this right here is also collidable. This right here is also collidable. And if we resize it, for example, just to be like this, then only that part will be collidable, but this part here will not, and this part here will not be collidable. But when we use a mesh collider, which is this one right here, then this whole game object like this is collidable. You see, where I'm drawing my red lines, it's collidable like that. The whole game object, the whole 3D model, how it looks like, it is collidable that way. Not like here when we are using a box collider. And this is the same for all other traps. So here we have the spear trap. If I select the spear and let me go back here, you see we have the spear, and simply you see what it's doing. It's simply firing. You see, firing, going back, firing, going back. It's simply an animation. Same for this one, for the saw right here. And if I select it here for the saw, we also have it, you see? It's simply an animation. That's why I did not want to go through all of that, because I would need to set all of these animations up and then animate all of these game objects. It would be a lot of work, and we would not learn anything that we did not know so far. And basically that is our game. So I can hit the play button here and I can play this game infinitely before I die. Your assignment may be, if you are willing to actually learn something, because I have a feeling that a lot of you guys are just coming here for the fancy games that I create. So you can create a score count, like measure meters, how many you pass. You can put that up there. So and going back here, you see I'm moving, and I'm pretty good at my own game. I think I am. So let's go, try not to, let's die here. And we died. So yeah, I died on purpose, so that doesn't count. But anyways, this is our game. If you want to practice, there are a lot of things that you can implement here. As I already said, you can implement the score, then you can implement the main menu as well. If you are actually trying to learn something and make a career out of game development, and not only comment, whoa, thank you instructor very much. So yeah, anyways, download the assets, and the complete project link will be in the description below. Thank you for watching. Share this video if you like it. Smash like, subscribe. notification button, comment, all of the good stuff, and fire here from usbtees.com. I will see you guys in another video.